Hello everyone, welcome to the Arjun Mech classes. Uh, Yesterday we discussed about the LPP formulations. So in that we solved one problem related to the formulations. And again, once again, I'm recapping that the formulation process. The first one is we should have the proper objective function for the problem, and along with that, we should have standard decision variables. So after that, we should have a proper constraint equations. Once we get a constraint equations, along with that, we should have a non-negativity conditions like a x1 and x2 should be greater than or equal to 0. Okay, so today also we are discussing one problem on the LPP formulation. So we have a problem here for producing two products X and Y. The labor requirement for the unit of products X and Y are 4 and 3 man hours. The processing time required for the units is expressed as 1 and 2 machine hours respectively. The raw material requirements are as follows, that is the 0.3 and 0.2 kg per unit. The weekly availability of the man hours, machine hours, and the raw materials are given as 100 man hours, 80 machine hours, and 30 kg respectively. It is estimated that the profit per unit of X and Y are rupees 5 and rupees 3 respectively. Formulate LPP. So this is a problem. So here we have to identify the proper objective function, and along with that we should identify the decision variables, and we should identify the constraint equations, right? So coming to the statements here, the first statement, it says a firm is producing two products, right? So X and Y, those product names are called as X and Y, and so these two products are going to become our decision variables. So what I will do is I will write the first statement here for the decision variables. Yes, then let x1 be the let x1 be the number of unit of its of X product produced per week. So and let x2 be the number of units of Y products produced per week. So what we did here, so we identify the two decision variables. So next work is what we have to identify the objective function. So we can see here, so in the statement he mentioned, it is estimated that the profit per unit of X and Y are rupees 5 and 3. So means this problem is having a profit function here. Profit means, so automatically the objective will become, he is going to the maximize. So then maximize Z equal to the 5x1. The objective function will become 5x1 plus 3x2. Okay, so once we return this objective function, next work is what we have to identify the constraint equations here. Objective function is done. So next work we have to identify the constraints. So what are the constraints here? So he is having a constraint over three different things here. One is on machine hours, and one is on man hours, and one is on raw materials. So we are having three different constraints. So means we are going to get a three constraint equations here. So coming to the first one, you can see here the man hours, the X first statement we can see here. The X and Y, the labor requirements for the units of products X, Y and X and Y are. So labor hours and the man hours required are 4 hours and 3 man hours are required here. Coming to the man hours equations, the constraint equations. Will become 4x1 plus 3x2 And second one, we have a processing time required for the units is expressed as 1 and 2 machine hours, and machine hours are x1 plus x 2 machine x1 plus 2 x2 here. The raw material requirements are 0.3 x1 plus 0.2 x2. So all the three equations we done here. So we should give a constraints. What are the limitation over all these three materials we have to process. So next, coming to the second line, next line, uh, the machine hours, raw materials are the man hours, machine hours, and raw materials are 100 man hours, 80 machine hours, and 30 kg. So he's having a restriction. So he can use only the man hours of around 100. So we can't exceed this for the more than that. So he's having limited. So then the machine hours are also limited. We can utilize only the 80 machine hours, and the raw material restriction is we can utilize only 30 kg of material. So if it exceeds, so then we can't proceed for our profit. It will become a loss, right? So he is having a limitation over this. Next one. So once the limitations are done, so next we have to go for the second process, that is the constraint equations, the non-negativity functions. So here we are having two decision variables, x1 comma x2. x1 comma x2 should be greater than or equal to 0. The decision variable should be non-negative. So these three statements we have to mention in all the problems. Thank you.